Why do you guys always cut it so close? What is it about the seniors that you have decided you are not going to enter the Zoom until the last possible second? All right. Well, for those of you that are here already on time, ready to begin, good morning and welcome. Today is the beginning of the end. This is the last section of our chapter on basic trigonometric functions. And so today we're going to look at applications of trig functions. So it's going to be, mostly word problems today. Everybody's favorite thing, right? We've got a couple things. I'm going to do a few examples for you, and then I'm going to try to leave most of the class for you to just go ahead and work. But before that, we have to take care of something that we didn't do Monday, the reading quizzes, which only has 1, 2, 3, 4. 4 word problems in it. So it should be short and sweet and give you a good variety there of some simple application questions as well as a few of the inverse exercises from Monday. Okay, Kaylin here as well. Excellent. So as not to waste any more of your time, here we go. Some applications of trig functions. Through that whole section, you could break them down into, they presented mainly 3 major types of applications here. The most common is just solving a right triangle. Okay, a lot of situations just break down into forming a right triangle and then using all of your known, since it's a right triangle, you automatically get the one angle, it's a right angle. And then as long as you have 2 other pieces of information, a side and an angle, if you have one of each, you can find pretty much any of the rest. That's the case, yes. Next chapter, we will get to see how we deal with what if you only have like 2 of the sides, or if you have all the angles but none of the sides, right? What do you do then? So right now, a lot of things break down to solving a right triangle just with the trig functions. Works beautifully. There was also the finding of bearings was another big application of trig there because it's dealing with angles, bearings being the direction you're moving in, right? What angle you're moving at relative to north or south. And that's a pretty good one. If you like navigation or being on boats, that's a great one. However, for our purposes and simplifying and streamlining things this year, I'm going to completely skip all of those. I'm not doing any examples on them. There are none on your exercises. There will not be any of those questions on the test. Okay, so forget the bearing ones. They're good. They're not exceptionally hard. I just had to trim things, okay? So sorry, bearings. You will be missed. Okay. But one thing I do like a lot of, and we'll definitely be including this, is this simple harmonic motion, because this is a physics question. Harmonic motion is any time something is repeating itself. Its motion is going back and forth. All right? It's almost, you might say, periodic in a way. Hey, didn't we talk about these graphs being periodic functions? Yeah, exactly. Right? So that is absolutely a great application for the height of something. Moving up and down would be a sine wave, right? Something bouncing. A lot of times they have some mass hanging on a spring, and it bounces up and down. Physically, when would you have just a box hanging by a spring like that? That's a little too idealized. But things moving back and forth anytime, right? You bump something and do I have my water bottle on camera here? Just barely, right? You tap it and it wobbles back and forth, okay? That is a type of harmonic motion. So let's get started, shall we? I'm actually going to skip the basic one. Here is a triangle. Actually, well, let's not skip it. I'm just going to overview it. How about that? Right? Once you've got a triangle set up, I have two sides. I can always find the third side with Pythagorean Theorem, right? A squared plus b squared equals c squared. That takes care of that. I've got the right angle, and then to get any other angles, I can easily use, let's see if I want, say, this angle, call it theta. Well, the sine of theta would be the opposite over the hypotenuse c, which I've already found with Pythagorean Theorem. Do it that way. And then, so you actually need to solve for that, so you'd want theta would be inverse sine of 111.4 over c. Okay, that works. My recommendation here, and this will apply to all future triangles, is not to use this one if it relies on something you already had to calculate, right? A better option would be go with tangent of theta would be the 111.4 over 125.3. They will both work. They will both get you a correct answer. The reason I recommend going with tangent is what if you screwed up your computation for C? Any kind of mistake, right, could happen. Not just like a rounding error, and so this could end up just being off by a little bit, but you wrote down something wrong, you miscopied it, you mistyped it into your calculator, and you don't want to carry any possible errors from this over into finding that, right? So always base it on as much original information as you possibly can. That's my tip for you there. Okay. How about a real example? Here we go. One of those harmonic oscillators. Okay. An object moves in simple harmonic motion described by d equals -3 sine 4 pi t, where t is measured in seconds and d is measured in inches. Find the maximum displacement, the frequency, and the time required for one cycle. Okay, we've got three things defined. They are, in fact, just three of our basic features of a sine function. Okay? The only thing that's changed here is now we've put it into context of, hey, there's a real physical thing that is moving this way. Okay? The function actually means something. If d represents its displacement, okay, what is the maximum displacement? How far from that center position can it possibly go? Well, you'd look at the amplitude of the function, right? What is being multiplied by the whole sine? Sine by itself, basic untransformed sine, has an amplitude of 1. Right? Goes to +1 and -1, up and down. But this, we multiplied everything by -3. So now the maximum reached is 3. And that's it. I just read that off of the equation. I didn't have to do any computation at all. Oh, this is easy. We're a third of the way through. How about the frequency? Okay, what is frequency? Frequency is how many cycles per second. Okay? How many times does it repeat itself in the span of 1 second? Okay? And this can be tricky to compute, because what you might think of doing is say, well, I can test it at what is d of 0, and that gives me some value, and try d of 1 second, and that gets me some value, right? And I could look right on the graph. We've got our sine function. I can say it goes from here to, oh, there's 1 second, right? So it goes half a cycle, or maybe it goes 2 cycles. But what if I actually land and I get 0? Okay, because this is a sine function. Honestly, it hasn't been shifted. D of 0 should be 0. What if D of 1 is 0? that doesn't tell me anything, right? So my recommendation would be to actually just graph it and look at it, okay? Because I don't know if it's going to look like this or if it's going to look like that, right? How many times does it go up and down before I reach my time of 1? Okay. So my recommendation is to just look at it, and we can find out. So let's go to Desmos calculator. -3 sine of 4 pi t. Where's my calculator? There it is. Here we go. -3 sine of 4 pi and our variable x. Oh my goodness. Look at that. Look at that. That's a lot here. Can I zoom in? Thank you. 1 is right. I don't think it'll let me go just horizontally. There we go. There we go. Okay, so bring that back down. So how many cycles do we have? It goes down, up, and back once, twice, and there's 1. 2. Our frequency is 2. And we usually call that hertz. Hertz is just a unit, that is 1 over seconds. Okay? 2 cycles per second. And finally, we want the time required for 1 cycle. Oh. Time required for 1 whole cycle. Well, this is really neat. That would be called the period, right? So we know how to calculate the period of a sine function, right? The default period is 2 pi, except we multiplied inside the x. Oh, it's inside parentheses, so it does the reverse, so it divides things. So to undo that, we're just going to take 2 pi divided by whatever we multiplied there. In this case, it was 4 pi. Okay, just taking that 4 pi there. 2 pi divided by b gives us our period. In this case, pi's cancel out, and 2 over 4 is 1/2. So t equals 0.5 seconds. You might also notice a little something related to the period versus the frequency. Turns out you can calculate the frequency from the equation rather simply. You just probably want to calculate the period first and then take the reciprocal of that, right? Frequency is 1 over the period. So 1 divided by 0.5 or 1/2 gets you back to 2. Okay, not actually that complicated. Any questions on that example? No? Okay, then let's go on to the second one. Here's a real example. Okay, this is going to be a triangle, but at least it's in the context. I wanted a good word problem example here. So, a 500-foot cliff drops vertically into the ocean. The ocean is always assumed to be then perfectly flat. If the angle of depression from the top of the cliff to a ship is 42 degrees, how far offshore is the ship? All right, so let's draw our situation here. We've got a cliff and the ocean. Right, perfectly vertical, so top of the cliff, this is then 500 feet. And we've got some ship here, right? There's a little boat, okay? It's out there, and here's the top of our cliff. Beautiful picture, right? So we want to know how far is this? How far is the boat? How far offshore is the ship? And all we know is the height of the cliff and the angle of depression from the top of the cliff. Angle of depression. Depression means you're down. So an angle of depression means measured down from the horizontal. So you go from horizontal downwards, okay? So that means we're looking at something from horizontal at the top of the cliff down. So it's this angle right here is our 42-degree angle. Wait a minute, that's not inside the triangle. Shoot. Mr. Apple, what are we supposed to do now? Have you forgotten your geometry already? These are parallel lines. Okay, the horizon and the ocean are parallel, which means this angle and that angle are alternate interior angles, so this is also 42 degrees. Now it's inside the triangle. Okay. Now we have our opposite side. We want to find our adjacent side. We know the angle. So set up our trig ratio. The tangent of 42 degrees will equal SOHCAHTOA opposite. So the 500 on top over x. Solve for x, multiply both sides, then divide by tangent. So x is going to be 500 divided by tangent of 42 degrees. There we go. All right, make sure your calculator is in degree mode, and I think we can do that on decimal. 500 divided by tangent 42. There we go. 218.2. We can round up 218 feet. Right? Okay, any questions on that one? Is it 218? No, that is not the answer I got. Whoops. Desmos, what are you doing to me? That's probably not in degrees. Let's check. Let's see if we can do it with this one. I think this has trig functions. 500 divided by the tangent, whoops. What are you doing? If I type 42, then tangent? Okay. That's the tangent of 42. So I need 500 divided by that. I don't know how this thing is going here. 500. 42. I hate these calculators that you can't actually type out what you're looking for. Look, 0.9, all right? You also got 218. Are you in degrees or radian modes? Because that's not the answer I have. I have 555. And that's what I got to see. So we can always check, okay? Sine of 30 degrees should be a half. I did not get a half. So I'm going to hit the dig. Let's go to degree mode. 30 degrees, sine, half. I'm in degree mode. Confirmed. So 42, tangent of 42 is 0.9004. So 500 divided by 0.9, 555. That's what I was looking for. Okay, if you got 218, you were in radian mode. That's probably the biggest trick on these. Okay? There we go. It's 555 feet. How do you switch back? If you're using the like TI-84, you're going to go to the mode at the top. Right up there. And you'll have a similar option somewhere there that says radians or degrees. Okay. Any other questions? Okay, then please go to joinmyquiz.com, enter the game code 655154, and we will start the quizzes. As always, retake code will be posted at the end of the class day, so 2:30-ish. You'll have the rest of the week to retake it, but I want to see how you're doing right now. So join on in, do your best. It's 12 questions on this one. Should be short, sweet. A few of them like this with the cliffs. Okay, so just make sure your calculator is in the correct mode, depending on the units they give or ask for. Four, five. Need one more. Okay. When you are finished with the quizzes, go ahead and move on to today's exercises. Get a head start on your homework. Okay. There we are. Go. And their music is way too loud for my taste. Okay, you guys do that.